PN gen okay, photodiode. Okay, so we will discuss today and some another parameters also. Yes, someone is unmuted. Mute yourself. M2. Mute yourself. Okay. Yeah. Now we are going to the lesson. Yesterday we discussed about the characteristics of the photodetector. We discussed some characteristics, that is the quantum efficiency and responsivity. Okay, so these two are both are proportional to with each other. Okay, that responsivity is proportional to the quantum efficiency. Already we discussed what is the quantum efficiency also. Okay, so we will discuss the whatever the significant parameters. So not only these two parameters, so there are another parameters also there. So for photodetectors, so here we will discuss about those important parameters of the photodetectors. Okay, first of all, so quantum efficiency is so one of the basic parameter. So it will be that the photodiode characteristics will be depends on the this quantum efficiency. If efficiency will be more means, so that photodetector will be work accurately. Okay, so what is the quantum efficiency? It is the ratio of primary electron hole pairs created photons to the photons incident on the diode material. Okay, yesterday we discussed. So here just quantum efficiency is ratio of number of electron hole pairs produced due to the so photon instant. If photon is instant on that diode, so electron hole pairs will be generated. So here how much will be generated? That means number of electrons hole pair generated due to the photon instant. Okay, by and so another ratio is another parameter is photons incident on the diode material. Here ratio of the electron hole pairs by number of electrons hole pairs by, so here number of photons incident on the diode material. This gives the quantum efficiency. Okay, now so already I explained you regarding about the quantum efficiency. If quantum efficiency is more means, so that diode will works more accurately. Okay, that quantum efficiency will be depends on the here. So how many electron hole pairs will be generated? How many electrons hole pairs will be generated if photon will be instant? If photon will be instant. So whenever this quantum efficiency will good means, so if you will take each photon will generate the one electron hole pair. So at that situation, quantum efficiency will be very high. Quantum efficiency will be very high, and maximum current flow through this circuit. Maximum current flow through that circuit. Okay, and next one, detector responsivity. This is the ratio of output electric current to the input optical power. Hence this is the efficiency of the device. The unit of responsivity is ampere per watt. Okay, so detector responsivity is just ratio of output electric current to the input optical power. Here optical power, so how much power of photons will be instant on light, how much power of light will be instant on the photon. Okay, that gives the optical power. So optical power means the intensity of the radiation into energy of the each photon, it gives the optical power. Okay, that here responsivity means ratio of the so current. Okay, if photon will be emitted on that photodiode means what happen? Current will be produces due to the charge carriers. Okay, here so we have to take the just ratio of the electrical current, how much current will be produced for photon power, optical power. Okay, this ratio, so electric current and so optical power ratio gives the detector responsivity. Okay, hence this is the efficiency of the device already. So we discussed this responsivity. So responsivity is proportional to the efficiency. Okay, so that's why if responsivity is more means that efficiency of the device also high. Efficiency of the device also high. Okay, now the unit of responsivity is the ampere per watt. Ampere per watt. Okay, now next one, spectral response range. Spectral response range. Yeah, someone is unmuted. Mute yourself. Okay, now spectral response range. Okay, if you will take the spectral response range, if you will take one diode, that diode will works up to particular region. That means wavelength region. Wavelength region. Suppose some diodes will work at only red region. Some wavelength will works at IR region. So some wavelength works at so blue region, like that. Particular wavelength, it will be works on a particular wavelength region, depends on the band gap of the valence band and conduction band. Band gap of the valence band and conduction band. Okay, so that's why spectral response range. So, this also will act as a more significant parameter for the photodetectors. Photodetectors. Okay, so we'll discuss about the this what is definition of this. So this is a range of wavelength over which the device will operate. Over which the device will operate. This spectral response refers to the curve of detector responsivity as a function of wavelength. Function of wavelength. Okay, here, so for which wavelength, how it will be response. Okay, in which wavelength region it will be response. So for which wavelength, suppose if wavelength will be less, so what is the value, output value? Wavelength will be high, what is the so output value? Okay, so that spectral response versus if you draw the wavelength of the instant radiation. If you draw this curve means, so we can get the spectral response range. Spectral response range. So initially, so while using the photodetectors, so initially they will find out the what is the spectral response for each wavelength. Each wavelength. So based on this curve, so we can calculate which wavelength is instant. Which wavelength is instant on the photodetector. Which wavelength is instant on the photodetector, because it will be photodetector mainly used as a sensor. It will detect the photons. It will detect the photons as well as, so which type of, that means which wavelength photon will be instant on that. Okay, so that means if you will take IR region, so that wavelength will be 9000 angstroms. 9000 angstroms. So if wavelength will be depends on this curve, spectral response and so wavelength curve. So we can say that, so we can say that that is the, so which wavelength is instant on the photodetector. Okay, that is the spectral response range. Spectral response range. So by using this spectral response range, so photodetector will works in which wavelength region. In which wavelength region. Some photodetectors will be works in particular regions. Particular regions. If you use that photodetector in another region means that will not works. That will not works, because that working also depends on the so energy gap of the that photodetector. So if energy gap will be small means, so what is that, so it will works at higher wavelengths. If energy gap will be more means, it works at lower wavelengths. Okay, so that's why, so depends on the spectral response range. So we can use the detectors in a particular application, particular wavelength applications. Okay, so this is the spectral response range. Next one, noise characteristics. Noise characteristics. The level of noise production in the device is critical to it operation at low levels of the light instant. Okay, yeah. So the level of noise production. So if suppose if you will take one diode, so that diode noise level will be very high. Noise level will be very high means it will not accurate at that means less intensity lights. Okay, low levels of light means less intensity lights. Okay, so because so noise will be very high means so if you just small very less intensity of light will be instant on means so we cannot detect by using photo detector. So that's why so this we can reduce the noise level. We can reduce the noise level for detect. Okay, so if noise level will be high means so we cannot detect the low levels of light instant, low levels of light instant. Okay, this is about the noise characteristics. Next, response time. Response time, this is the measure of how quickly the detector can respond to variation in the input light intensity. Okay, after instanting the light, so some diodes will work within fraction of seconds, some diodes will take so some time. Okay, so that means it will be depends on the response time. If response time will be very less, if response time will be very less means so those will act as a good photo detectors, those will be a good photo detectors. Okay, so this is about the response time. So response time should be very less. Response time should be very less. What is the response time means? So whenever light will be instant on the photodiode, so how much fast, how much quickly the detector detects, the detector measures. Okay, so that is the response time. If response time will be less means, so the diode will works very accurately. Okay, now next gain. Okay, so gain. So this is the avalanche photodiode have more gain than PN diode due to the effect of impact ionization as it is operated high at a high electric field. Okay, see here. So gain means suppose if less intensity, already we discussed that. So if less intensity of light is instant means so output will be very small. Output will be very small. Okay, so sometimes we cannot detect that output also. We cannot change the that means if you will take PN junction diode, generally PN junction diode, if you connect in reverse bias, what happened? Initially, due to some electrons, minority charge carriers, what happened? Current flow through this circuit. Current flow through this circuit already. So that current we will call it as reverse saturation current. Reverse saturation current. In case of photodiode also, it will be same. So it also connected in reverse bias. So without instant on the light also, there will be little amount of current. Okay, after some less intensity light will be instant. On the photodiode. What happened? Small amount of current will be increases. Okay, so that means some detectors having gain is very less. Okay, for less intensity its gain will be very less, output gain, and that means the increasing of the output current is so very less. Okay, at that situations we cannot measure the difference between the initial current and so after the light instanting. Okay, so that means we cannot measure the change, we cannot detect the changes of initial current and final current. So that's why it should be high gain operator. So if it will be high gain diode, photodiode, so that will be very useful. So here if you observe this, so compared to PN diode, so now we are discussing about the PN photodiode. So compared to the PN photodiode, PIN photodiode have so more gain. PIN photodiode have more gain. That means sorry, avalanche photodiode, APD photodiode is more highest gain compared to the PN diode. Okay, this is about the gain. Okay, now next rise time. So we'll discuss about the rise time now. The rise time is the time for detector output current to change from 10 to 90% of its initial value when the optic input power variations is a step. Okay, yeah, now so rise time is nothing but if photon is instant on that initially, so there is a initial some current is passing through that in the diode. So if you increase the intensity of the light, if you increase the intensity of the light, so output will be changes, so how much time take, how much time will take to rise from 10 to 90%. Okay, how much output current will change from 10 to 90% of whenever increasing the input incident radiation, input incident radiation. Okay, if rise time will be high, if rise time will be, sorry, if rise time will be less, rise time will be less, so that photodiode will works very accurately, will works very accurately. If rise time means, so it will increasing from, so 10 to 90%, 10 to 90%, while changing the, while changing the input power, while changing the input power, so what happened, output current also changes. So if you, after changing the input power, how much time take, how much time take, take the, what is that, output from 10 to 90%, thus that time we will call it as rise time. If rise time will be less, if rise time will be less means, that photo detector works will very accurately. Okay, so these are the some parameters about the photodiode. While preparing the photodiode, so we'll consider, so we will take the consideration of these all parameters, all parameters. So if all parameters are very accurate, so that diode will works very accurately. That diode will works accurate, very accurately. Okay, so we should consider the these parameters while preparing the diode, photodiode. Okay, so this is about the, so what is that significant parameters of the photo diode or photo detectors, photodiode or photo detectors. Okay, now coming to the operation regimes of illuminated junction. Okay, so operation regimes means, so operation modes, how many, so how many modes we can operate, how many modes we can operate that illuminated junction. Okay, so here this is the diode, here this is diode, this diode is, so how many modes we can take, so that is the, so operation regimes. So here generally we are taking two modes of operations, two modes of operations. So first mode is as a photo detector, photo detector. Second mode is photovoltaic device, photovoltaic device. So in photo detector, how we are connecting means, in photo detector mode we are connecting in reverse bias, reverse bias. And in if you will take photovoltaic mode, if photovoltaic mode will not connect any external voltage here, we are not connecting any external voltage here. Okay, so this is the zero bias mode, zero bias mode. Okay, and see here, third coordinate, external reverse bias, reverse current. If you will observe here, so this reverse bias and reverse current will be in third coordinate, third coordinate. Okay, so now here, so it will be in, so operating point, this is the operating point, that operating point at fourth coordinate. Fourth coordinate means, so voltage will be forward bias and current will be reverse current, current will be reverse current. So this is the, so what is that operating point for photovoltaic cell, photovoltaic cell. Okay, we'll discuss this photovoltaic cell later. Okay, that so yeah, examples for photovoltaic cell is solar cell. Okay, solar cell or energy harvesting cell. Okay, this is the, so example for photovoltaic cell. So that means this is only, both in both cases, this is photodiode only, photodiode only. So one case it will be act as a photo detector, another case it will be act as a photovoltaic cell, photovoltaic cell. So what is the case means, here, here we are connecting in reverse bias, here we are connecting in zero bias, zero bias. Okay, so in two different modes it will be works as a, so differently. Okay, so first we will, so one more time we will discuss about the modes of operation. Okay, photodiode can be operated in two modes. So first one is photodiode, so photoconductive mode, photoconductive mode and reverse bias. So that means we can also call it as, this is the photo detector mode also, photo detector mode also. Okay, so that is photoconductive mode or photo detector mode or reverse bias mode, reverse bias mode. In photoconductive mode, the diode is operated in reverse bias. Okay, which which in turns dramatically reduce the response time at the expense of increased noise. Okay. Consequently, faster response time can be achieved by increasing the depulsion layer and decreasing the junction capacitance. Photodetectors are operated in photoconductive mode. Okay, already some parameters we discussed above. So how can reduce those parameters? So how can make those parameters accurately means so by using connections here. Okay, so once again I am discussing here photoconductive mode. So this is a diode is operated in reverse bias. Okay, so we have to how to reduce the response time means so the expense of increased now. Yeah, so dramatically reduce the response time at the expense of increased noise. So that means while reducing the noise, so we can increase the response time. Okay. Consequently, faster response time can be achieved by increasing the depulsion layer. So width of the depulsion layer will be, if you increase the width of the depulsion layer, what happens? So automatically the response time will be decreases and decreasing the junction capacitance. So and we have to reduce the junction capacitance also. While reducing the junction capacitance also, we can increase the response time. We can increase the response time. Okay. Uh, so photodetectors are operated in reverse bias mode or photoconductive mode. Okay, this is about the first mode, that is the photoconductive mode, and second one is photovoltaic mode. Photovoltaic mode. This mode is use the photovoltaic effect, so which is fundamental for solar cell. When used in zero bias or photovoltaic mode, the flow of photocurrent out of the device is restricted and voltage buildups. Okay, see here. So this is the photoconductive mode. That means we are connecting in reverse bias. This diode is connected in reverse bias. So this is the photovoltaic mode. That photovoltaic mode. So we are not connecting anything here. So just we will connect the resistor. So what happen itself? It will develop the some voltage. It will builds the some voltage itself. It will builds the some voltage in case of photovoltaic mode. So itself that diode will builds the some voltage. Okay, so that is the photovoltaic mode. So regarding about this photovoltaic mode, we will discuss in solar cells. We will discuss in solar cells. Now, so what we are discussing, photoconductive mode. Photoconductive mode, this is the in case of photodetectors. In case of photodetectors, this conductive mode will be we will discussing in photoconductive mode in photodetectors. Okay, now so characteristics for operating modes. Okay, so this is the so how curve will be there in photoconducting mode or photodiode mode. So in case of photodiode mode, so whatever the reverse characteristics of PN junction diode, so reverse characteristics of the PN junction diode, same like the Tony. See here, if intensity will be very less means, so that current will be so like this. So the current will be in case of reverse bias, reverse characteristics of the PN junction diode. What happened? So current will become constant. So reverse saturated current. So reverse saturated current we will discuss now. So this is the current will become constant here. Okay. So now if you increase E1, E2, E3, what is E1, E2, E3 means? So this is the power of incident radiation, power of otherwise intensity of incident radiation, intensity of incident radiation. If you intensity will be increases, reverse saturation current will be increased. Reverse saturation current will be increased. Okay, so this is in second part. So right side part will be the in case of photovoltaic cell. Photovoltaic cell. So in case of photovoltaic cell, so it initially so that what is that resistance will be very high. Resistance will be very high. So what happened while increasing the intensity of light? So that resistance will be reduces. Resistance will be reduces. Okay, and that current will be like this. That current will be like this. So up to particular voltage, that current will be in fourth coordinate. So after particular voltage, that current will increases very drastically. This is in case of photovoltaic cell. Okay, now we will discuss about the photodiode. Okay, this is just, so here we are discussing two modes. So one is the photovoltaic mode, another one is the photoconductive mode. So for working of the solar cell will works in photovoltaic mode, and detectors will works on photoconductive mode. Photoconductive mode. So these photodiodes are photodetectors. Photodiodes are photodetectors will works on photoconductive mode. Okay, now we will discuss briefly about the so this photodiode. So just light sensitive electronic device capable of converting light into a voltage or current signal. Okay, so see here, so the photodiode is a light sensitive electronic device. Light sensitive electronic device. That means whenever light will be falling on it means, so it will be very sensitive. It will be very sensitive. It will detect that light. It will detect that light. It absorbs that light and it will convert into either so voltage or current. That means, so here in case of photodiode, light energy is converted into electrical energy. Okay. It works on the principle of photogeneration. It works on the principle of photogeneration. Photogeneration means here, so when light is incident on that, so that light is absorbed by that material and covalent bond will breaks. Covalent bond of the material will breaks. So if covalent bond will breaks means, so electron hole pair will be generated. Electron hole pair will be generated. So based on, so this principle it will works. Based on this principle it will works. Next, the symbol of photodiode is shown like this. So this is the symbol of photodiode. In case of LED, so what symbol will be, so that arrows will be outside. Arrows will be outside. That means that is the meaning of light will be emitting. In case of LED, light is emitting. Okay, in case of photodiode, see here, so this is normal diode symbol only, and only that arrows will be inside. Arrows will be inside to the into the diode. Arrows will be into the diode. That means, what is the meaning of that means? It absorbs the instant light. It absorbs the instant light. See here. So one is the anode. So this is the anode and this is the cathode here. Okay. Uh, so this diagram. Observe this diagram here. So one terminal is connected to the anode and another terminal is connected to the, so the cathode. See here. So this is the, so we will discuss that is deeply. Okay. Next, and semiconductor photodiode is a reverse biased PN junction diode. Semiconductor photodiode is a reverse biased PN junction diode. Already we discussed. So in case of, so LED, in case of LED, if you will take that PN junction diode is connected in forward bias. Forward bias. But in case of photodiode, that same PN junction diode, it is connected in reverse bias. It is connected in reverse bias. So one more thing we have to remember here. So this depulsion layer should be more, we discussed here. If depulsion layer, width of the depulsion layer will be more means, so this will be some response time of the photodiode will be high. Already we discussed in previous case. If depulsion, width of the depulsion layer will be more, so response time will be very high. Response time of the photodiode will be very high. So when it will be so reverse bias, so that depulsion layer width will be increases when and we at which condition depulsion layer width will be more. So that means that doping concentration will be less. Doping concentration will be less. In case of P region and N region, if doping concentration will be less means width of the depulsion layer will be high. Width of the depulsion layer will be high. But in case of LED, what we are discussing, so that that should be small. Width of the depulsion layer will be small. When it will be small means, so it is high doping. So the P region and N region will be heavily doped. Heavily doped. So at that situation, width of the depulsion layer will be decreases in case of diodes. Similarly, in case of photodiodes, so what happened is width of the depulsion layer should be more. Width of the depulsion layer should be more. So for that, so what we are taking, so that what is the doping concentration will be, we are taking very less. Doping concentration we are taking very less. That is the difference between the LED and photodiode. LED and photodiode. In case of LED, width of the deposition layer will be small. In case of photodiode, width of the deposition layer will be high. And one more thing, doping concentration is very high in case of LED. In case of photodiode, doping concentration is very less. Okay, those are the difference. So and LED will emit the light. So photodiode absorbs the light. Photodiode absorbs the light. If you compare like that, means you can easily remember. You can easily remember the some points regarding about the photodiode. Okay. Now, so next one, the structure of photodiode is shown below here. So here structure is similarly whatever the LED structure will be there. Here photodiode structure also same. So yes. Okay. Now see here, this is the metal substrate same. So how to prepare the LED also same like that only. Here also we will that means construction of this photodiode also same like LED. Okay. So how to construct that means, so first of all we have to take the one metal substrate, and that metal substrate N region will be dope. So by using physical vapor deposition method or chemical vapor deposition method or any other method, we'll deposit the N layer. We'll deposit the N layer. That N layer diffuse. That N layer diffuse on the metal substrate, and so one thin layer will be formed here. One thin layer, N-type layer will be formed. So on that N-type layer, again P layer will be deposited. Okay, P layer will be deposited. So that P layer diffuse on the N layer, and there will be junction will be formed in between the P region and N region. P region and N region. Okay. Similarly, here for N region and P region, so we are connecting the metal contacts to supplying the power here. Okay, so to supply the voltage, so we are taking, so that means these will act as a anode and cathode. Okay, so this is the side view of the photodiode. Okay, so in case of P region, so there will be some gap will be there. That means only in case of P region, so only metal diode will be connected on the edges only. Okay, and why means here some space is required to emit the light. Instant the light. Not emitting, instant, some space is required to instant the light here. Okay, so that's why we'll leave some gap. Okay, on the P region. Okay, so this is the side view of the PN junction diode, that is photodiode here. Okay, now this is connected in reverse bias. Reverse bias means, so see here, so this region is connected to the N region is connected to the positive terminal, and P region is connected to the negative terminal. So this is the, so by using resistor, so we will connect it here. Okay, now coming to the structure. So just before we discuss the structure, so first of all, N-type layer is grown on a substrate, and P-type layer is grown on it by the process of diffusion. Okay, so first N-type layer is grown on the metal substrate. We will take the metal substrate, and that metal substrate N-type layer is grown on that. Okay, and so on the N-type N region, P-type layer is grown on. So grown on it. Okay, P-type layer is grown on the N region. Okay, by the process of diffusion. Okay, next, so second point is two ohmic contacts are made at P and N-type semiconductor, in which one ohmic contact act as a anode while other act as a cathode. Okay, see here, so one is act as a anode, another one is act as a cathode, Okay, now the ohmic contact connected to the P region in such a way that it allows the light to fall on the device. Okay, see here in P region, so this ohmic contact is nothing but metal contact. That means which are the following materials to follow the Ohm's law. So ohmic materials means, so which materials will follow the Ohm's law? That should be so all metals will follow the Ohm's law. So that's why here metals. So simply we will consider it as a metals. Okay, so two metals are connected in a P region. Okay, so that in between there is a some gap will be there. Why that gap means? So for instanting the photon on a device, instanting the photon on a device, there should be some gap will be there. So the gap should be there. So that's why. So here metal contacts will be connected and only edges of the P region. Okay, and we have to consider one more thing is that width of the P region is very small. Width of the P region is very small. Okay. Now, so working of photodiode, working